So here we have to learn in this chapter some of the main topics like electric current and next electric potential and potential difference. What is electric potential and its potential difference? And next we have to learn about electric circuit and how it is works. And next we have to learn about electric circuit symbols, some of the electric circuit symbols and its components. And next we have to learn about ammeter and next voltmeter. So what is the difference between ammeter and voltmeter? We have to learn this one. And next is there is a resistance. So what is resistance and what is the formula of resistance and what is resistivity? We have to learn. And next, what are the factors affecting the resistance? It is a very important question for the basis of examination point of view. You have to learn factors affecting the resistance also. And next, resistivity table. So here it is not necessary to buy this table for the examination. So you have to keep in mind. So how the resistivity can improve the conductor and insulator. So depend upon resistivity, we have to bifurcate the substances or materials into conductors and insulators. And next we have to learn about resistance and resistivity. Next there is combination of resistance. Combination of resistance, in that we have to learn about two combinations. One is series combination and another one is parallel combination. So here resistance are in series. So if resistance are connected in series, so how they are working? And next, if resistance are connected in parallel, how they are working? So we will learn in this chapter. And next, there is a main topic of this lesson is Ohm's law. So we have to study about Ohm's law. So and what is Ohm's law and how it works, we have studied in this chapter. Okay, dear students, first of all we start with electric current. Okay, so first of all we know that what is meant by current. Current means movement of materials. For example, just we can see that if water is flowing, that is called as water current. If wind is blowing, that is called as wind current. So here what is happening? The wind particles are moving and next water particles are moving, they are causes the current. So here electric current is nothing but electrons are moving. So first of all we can think that, so how the electrons are moving in the electric circuit. So just we have to understood that how the electrons are moving and how we are showing the direction of currents. Okay, first of all electric circuit, in that electric circuit, how the electrons are moving. Okay, first of all electric current. What is meant by electric current? Electric current is nothing but it is the rate of flow of electric charges. It is the rate of flow of electric charges or electrons through a conductor, that is called as electric current. So here electric current, it is denoted by the symbol I is equal to Q by T. So here the Q indicates the charge, T indicates the time. So here where I stands for the electric current, so here it is the scalar quantity. You know that physical quantity, scalar quantity and vector quantity. So what is meant by scalar and what is meant by vector? Scalar is nothing but the physical quantity which has only magnitude, there is no direction, that is called as scalar quantity. If it has both direction and magnitude, that is called as vector quantity. So here the current is called as scalar quantity because it has only magnitude. And here its SI unit is coulomb per second. Coulomb per second is called as ampere. Coulomb per second. So why means, so here Q is nothing but the charge. Charge are measured in the coulomb and time is measured in the second. So that's why coulomb per second it is called as ampere. The current is always measured by using ampere. It is a unit of current and it is measured by a device called ammeter. The current What is ammeter? Ammeter is a device which is used to measure the electric current. So further we can discuss about ammeter and the voltmeter in the next section. Okay, so here it is measured by a device called ammeter, and its direction is taken opposite to the flow of electrons. So here electric current. So the direction of current is taken. So if consider, so here this is a one of the conductor. So if it is a conductor, so this is connected to which one? Negatively charged. So negatively charged means, so electrons are moving like this. Electrons are moving like this, but we are taken electric current direction opposite to the electron movement. So this is electrons are moving in this direction means we are taking opposite the electric current direction. So that's why it's a direction of current is taken opposite the flow of electric charges or electrons. It flows as a result of potential difference across the ends of the conductor. So here just we can perform. So we can think about the potential difference. Here the word given the potential difference. So if any difference, any level difference is there, then only the materials or objects are moving. So we can learn about the potential difference. So here the current is flowing. So means current is moving from negative charges are moving in this direction means we are taken the direction of current opposite to the movement of electrons. Next we have to learn about the electric potential. So what is meant by potential? Electric potential. So here it is the amount of work done in bringing a unit positive charge from infinity to given point in the electric field. It is also a scalar quantity. Its SI unit is joules per coulomb, or it is called as volt. So here, dear students, we have to learn about the electric potential. Electric potential means nothing but the amount of work done to carry a one charge from one place to another place. So here, electric potential V is equal to W by Q. So W is nothing but work done. So work is always measured by a unit called as joule, and charge. 1 coulomb of charge we can carry from one place to another place. For example, point A to point B. If we carry the point A, electron of point A we have to carry to point B. So we have to do some work. It means displacement of any electron. So this can work done. So this is work done W by Q means joules per second. So this is the potential difference. Okay, to understand the potential difference, so just we are doing or we are performing a simple activity. So for example, consider, so if it is a pipe, so here if it is put in straight line, what will happen? So if we put water, so water is not flowing because of there is no level difference. If I make one end of the pipe is upside and one end of the pipe is downside, what will happen? There is a level difference. So here whatever the water particles are there, they can put pressure. So when they can put pressure, what will happen? Remaining particles are flowing, are moving. So this type, the potential difference can occur. Level difference will happen. So due to that pressure, the water molecules are moving. So like that, as the same way, what will happen when we apply any battery or when we apply a source of electric current? So in that time, what will happen? The electrons are getting the electric pressure. That electric pressure is called as electric potential. So when electrons are get electric potential, one electron, so it can put pressure on another electron. So like that, the electrons are moving. So when the electrons are moving in this direction, the current direction we are taking opposite to the movement of electrons. Okay. So next, electric potential and potential difference, we know that how it is. And next, potential difference. So it is the amount of work done. Already I said So you need positive charge one point to another point. We have to carry, that is in the electric field. It is scalar quantity and its SI unit is volt. And next it is responsible for the flow of electric current. Okay, potential difference is responsible for flow of electric current and it is measured by using a device called as voltmeter. Okay, dear students, voltmeter and ammeter. Just we have to keep in mind, ammeter is a device which is used to measure the electric current, but voltmeter is a device which is used to measure the potential difference. Okay, so here electric circuits. So before we are going to start electric circuit. So electric circuit, there are two types, and open type and closed type. So in the open type, no current flows, and in the closed type, the current will be flow. So here just we can see here. So here the two type of electric circuits are given. So here a closed path in which electric current can flow is called as electric circuit. So continuous and closed path in which electric current are flowing, are moving, so that is called as what we are calling for that one, electric circuit. So in the electric circuit, the current can flow. So here there are two types. One is open type, no current flows, and in the closed type, the current will be continuously flow. So this is about the electric circuit. And next, electric circuits and its components. So what are the components we are using? So this is very important, we have to learn. So here electric component, first we have to see that cell. So how the cell is there? Cell is containing two terminals, one is positive and a negative. Okay, positive we have to mention as a big line, and negative we have to mention as a small line. So negative indicates, so just we can see negative is nothing but electron movement, but current direction we are showing in the positive direction. So electrons exactly opposite of electrons. If the electrons are moving in this direction, obviously we have to put the direction of current in opposite to the movement of electrons. So it is a electric cell. And here, what is battery? A combination of cells. If two or more cells are connected continuously, so that is called as battery. So one is positive, negative, positive, negative, positive, and negative. So positive terminal and negative terminal continuously we are connected. So it can be a electric battery. And next, plug the key or switch open. So here the open switch is there. So and next is closed switch. And next, wire joint. If two wires are connected, so here these two are wire joint, and next wires without joint. So there is no joint of wires. And next, electric bulb, it is denoted by this symbol, and electric resistance. So here resistance means what, and what is the formula of resistance, and what factor the resistance will be depend. So we have to learn in the next further session. And next, variable resistance, or it is called as rheostat. And next, ammeter. Ammeter, already I said, ammeter is the device which is used to measure electric current. And next, voltmeter. Voltmeter is also a device which is used to measure the potential difference. So these are the main electric components which we are used in the electric circuits. Dear students, you should be copying these all, and you have to practice. Next. Okay, so here already we discussed about the ammeter. So here the ammeter, so ammeter positive and negative end, and here it must be connected in series in the circuit. Okay, whenever we are connecting the ammeter in the circuit, we have to connect this ammeter must and should in the series only. Okay, positive side of the ammeter must be connected to nearest to the positive terminal. Okay, just you can see here, positive terminal is connected to positive and negative terminal is connected to negative. Okay, so here terminal of the battery are electric cells and vice versa, means positive is connected to positive and negative is connected to negative. Just we have to see the what is ammeter and how this one is connected in the battery. Ammeter is a device which is used to measure electric current, and it is always connected in the series only, and positive is connected to the positive only, and negative is connected to the negative terminal of the battery. And next, there is a voltmeter. Voltmeter must be connected in parallel to the circuit. Okay, in the circuit, voltmeter is connected in the parallel. Okay, just next how the ammeter is connected and how the voltmeter is connected, we have to study in the combination of resistance only. Okay, the positive side of the voltmeter is connected to positive terminal of the cell and vice versa. Same how we are connecting ammeter. So at the same way we have to connect the voltmeter also. So just we have to getting one important question on this main topic. So what is the differences between ammeter and voltmeter? Just dear students, how you are writing your answer means, so ammeter is a device which is used to measure electric current, voltmeter is a device which is used to measure the potential difference. Ammeter is a device always connected series in the circuit, voltmeter is a device always connected parallel in the circuit. Okay, so you have to write these two differences and get a good marks. And next Ohm's law. So we have to study about the Ohm's law. So what is Ohm's law? Ohm's law means what? So first we have to learn about who stated this law. Okay, so here George Simon Ohm. So he was the scientist and he stated the law. So according to this law, so it states that at a constant physical condition like temperature are kept constant, the amount of current flowing through a conductor is directly proportional to the difference across its end or potential difference. Just we can see here, consider this is current, it is I, and next so here this is a potential difference. So George Simon Ohm can give the difference, can give the relation between which one, current and potential difference. What is the relation of these two? So current and potential difference both are directly related or directly proportional. So here if we increase the current, automatically the potential difference is also increased. So here according to this law, it states that at the constant physical conditions like temperature, if temperature remains constant, in that time the current flowing through that circuit is directly proportional to potential difference across the conductor. So here given that I is directly proportional to V, or V is directly proportional to I. If we increase the potential difference, automatically the current of the electric circuit is also increases. If we decrease the potential difference, the current is also decreases. So here V is equal to IR. So when R is taken as a proportional constant, that is called as resistance. According to this law, conductors are divided into ohmic conductors and non-ohmic conductors. We are learning in the higher sections. Okay, so here we have to learn about the Ohm's law. So Ohm's law is nothing but Ohm's law is it gives the relation between potential difference and electric current. So how the potential difference is increases at a constant temperature, current is also increases. So this one we have to learn. Okay, next we have to learn about the resistance. So what is resistance? It is defined as hindrance or to flow of current. So what is the hindrance to flow of current? It means, for example, just we can see, so in a straight road, a vehicle is moving very fast. What will happen? If vehicle is moving very fast, if suddenly what will happen? Road breaker will come. So in that time, what will happen? The driver, so who can ride the bike, so he can apply the brakes and he can reduce the speed. So in the same way, what will happen? When the current will flow in the electric circuit, in that time there is some opposition of the current, opposition to the current. That opposition is called as resistance. It is defined as the hindrance or opposition to the flow of electric current. If anything which can oppose the electric current, that is called as resistance. Okay, so here it is the ratio of potential difference and current, that is given that R is equal to V by I. So according to the Ohm's law, V is equal to IR, R is equal to V by I. So here R is nothing but resistance, V is nothing but potential difference, I is nothing but electric current. Okay, so here we have to learn about the SI unit of this which one? Resistance. So its SI unit resistance is, so here volt per ampere. Volt per ampere is nothing but that is ohm. So here reciprocal or resistance is called as conductance. SI unit is ohm per meter. So ohm per meter. Okay, so this is about the which one? Resistance. So here we can see that highest resistance in low current, lowest resistance in high current. So for example, if resistance is high, in that time the current is very less. If low resistance, in that time the current is very high. So this is about the resistance. And next there are factors which can affect the resistance. On what factor the resistance of the conductor is depends. So here the resistance of a conductor is directly proportional to the length, and resistance of conductor is inversely proportional to its area of cross section of conductor. Okay, so here just we can see that the resistance is directly proportional to the length. If the length of the conductor is increases, for example, if it is very small conductor, so in this what will happen? The current is more. If current is more means resistance is less. So if we can increase the length of this wire, in that time resistance will increase, current will become less. So here resistance is directly proportional to the length. If the length of the wire is double, or means triple, it means if we can increase the length of the wire, automatically the resistance of the wire is also increases. And here resistance is inversely proportional to area of cross section. If we can increase the area of cross section of wire, the resistance will decreases. If we decrease the area of cross section, resistance is increases. From 1 and 2, so we are getting R is directly proportional to L by A. R is equal to rho L by A. If we can remove this proportionality symbol, so we have to take an rho. So where rho is called as specific resistance or the conductor, it is called as resistivity. Okay, just here we have to observe this one. So here this is the area of conductor. So area of conductor, if it is increases, resistivity is decreases. If it is decreases, resistivity is increases. And here length is increases, resistance is also increases. If length is decreases, resistance is also decrease. So dear students, so here we have to learn resistivity table. Okay, so here silver, copper, gold, aluminium, tungsten, iron, steel, platinum and lead and nichrome, so gold and germanium, silicon, human steel, glass, rubber and next sulfur, so quartz. So these all things are given. So when we observe this table, so resistivity is less here and resistivity is more depending upon the resistivity. So we have to say that conductors and the insulators. So this is a good conductor. So this is a good conductor. So these are good conductors. So here the metals are good conductors because of they can easily help to flow the electrons from one place to another place. And next we have to learn about resistance and resistivity. So already we know that. So combination of resistance. So combination of resistance. So there are two types of combination of resistors. One is a series combination, another one is a parallel combination. How they are present. So first of all we have to learn about the resistors are in series. So how the resistors are connected in the series. So just we can see here resistors, they are here the three resistors. One is R1, R2 and R3. So they are connected to the battery, so to the cell. So positive and negative terminal. So here in this figure shows there are three resistors R1 and R3. So R2 and R3 connected in series. Okay, now we have to take R1 potential difference V1, R2 potential difference V2 and R3 potential difference V3. Okay, potential difference R we have to take V is equal total potential is equal to V1 plus V2 plus V3. So here we are taken these three potential difference. First we have to learn about according to the Ohm's law, V is equal to IR, V1 is equal to I1 into R1, V2 is equal to I2 into R2 and V3 is equal to I into R3. Okay, so just we have to in this we have to see potential difference is different, current is same. So because these are all connected in the series, when we are connected resistors are in series, the current will be same, potential difference will be different. Okay, so that's why according to Ohm's law V1 is equal to IR1 because the current will flow with same rate. There is no division of current. So current will flow at the same rate. If we can give 5 ampere of current, so it will move in all these three resistors, same current will be moved. Okay, so here according to total V is equal to V1 plus V2 plus V3. So according to this V is equal to IR, V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. So here IR is equal to, if we can take I is the same R1 plus R2 plus R3. So here I get cancelled. Total resistance in the series R is equal to R1 plus R2 plus R3. So therefore we concluded that sum of total resistance in series resistance connection are equal to the sum of all resistors. Okay, so just one example. So here R1 is taken as a 2 ohm, R2 is taken as a 4 ohm and R3 is taken as a 6 ohm. So what is the total resistance? Total resistance is equal to R is equal to R1 plus R2 plus R3. It means first one R1 is 2, R2 is 4, R3 is 6. What is the total resistance? That is obviously total resistance of this conductor is 12 ohm. 2 plus 4, 6, 6 plus 6, 12. So this is about the resistance are in series. Okay. So next we have to learn about the resistance are in parallel. Okay. How in the parallel circuit? Okay. So we already learned about the in the series. Resistors are connected in the series. There is a current will be same. If resistors are connected in parallel, the current will divide. For example, just you can see, so through this the current will be flow. So this is I total current. When it is comes to pass with the three resistors, they are connected in parallel. So it will goes to I1, I2 and I3. Again it will passes and again it will become I current. So this is we have to keep in mind. So in that previous what is that resistors are connected in series. In that time we are taken potential difference is a different. In this current is taken as a different. So I is equal to I1 plus I2 plus I3. So here by when we applying, so same thing. So R1, R2 and R3 are connected in parallel. So same thing will happen here. I is equal to I1 plus I2 plus I3. So here applying the Ohm's law, we know that V is equal to IR. So here I is equal to V by R. So according to Ohm's law, I is equal to V by R. So I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R3. Because potential difference is same here. Potential difference is same. So that's why V by R1, V by R2, V by R3 we are taken. So here by substituting these things, so first one I is equal to V by R, I1 is equal to V by R1, I2 is equal to V by R2 and I3 is equal to V by R3. So here V by R V by, so we taken V as a outside, so 1 by R1, 1 by R2, 1 by R3, so here V we get cancelled. So parallel combination, they can use total resistance of parallel combination 1 by R is equal to 1 by R1, 1 by R2, 1 by R3. So that's what we have to take this one. We concluded that sum of total resistance in parallel resistors are connected is equal to sum of reciprocal of their all resistors. So this is about the total resistance and the resistance in the parallel series and series connection of the resistance we already learned. Okay, these are about electricity, and we have to practice these things. It means Ohm's law is very important. You have to practice Ohm's law. What is Ohm's law and its expression V is equal to IR. You have to follow. And next you have to learn about a combination of resistors. Resistors are in series and resistors are in parallel, and you have to solve the problems based on these resistors. And next we have to learn about which one, electric circuits and their components, and what is electric current and what is potential difference. So these are you have to practice for the examination. Thanks for watching me. Thank you. Hello students, my name is Sslc. So here basically what should we learn? So in the magnetic effect of electric current, so we should learn about first of all we learn about magnet, and next Austin experiment. So here magnet and what are the properties of magnetic field lines, and next Austin experiment we should be learn, and how the direction of current in the direction of magnetic field in the straight current carrying conductor and the circular loop. So we should learn in this topic. And next there is a right hand thumb rule. So it is a very important rule. So it is given by Maxwell. So his right hand thumb rule also we should learn in this topic. And next there is a magnetic field. So how the it is a bar magnet. So around the bar magnet, how the magnetic field lines are generated or created. So we should learn. And next there is this is a solenoid. So in this solenoid, how it is also behave like a bar magnet, and how the magnetic field lines around the this bar solenoid we should learn in this topic also. And here there is a solenoid, it is a circular loop. So here also we should learn how the magnetic field lines are present and how this is working. So working of this solenoid also we should discuss in this chapter. And next here a strong magnetic field inside the solenoid. So this also we should learn in this chapter. And next this is the motion of the magnet with respect to coil and produced induced current. So this is coming under electromagnetic induction. So this is also we should be learn. And next so here Faraday's experiment. So that is electromagnetic induction, self-induction and mutual induction. So what is the difference between self-induction and mutual induction? So here there are two coils. So if one coil gets electric current, so this can produce a magnetic field. So this magnetic field can pass in this also. So this can be produced one of the phenomena. So this is also magnetic effect of electric current, and mutual induction also we should be learn. And next we should be learn about the Fleming's left hand rule and right hand rule also. So there are two rules, left hand rule and right hand rule. So in this topic we should be discussed. And here this is the Fleming's right hand rule. And next the difference between alternate current, AC current and DC current, and what how it is generated and how the direction. If it is DC direct current, it is not changes the direction. In the alternate current, there will be a change of the direction of electric current. So here, electric current, how supply for the electric current for domestic purpose and household. So how the electric current will be passes in the house, we should be learned. And next, there is a few factors. So here electric fuse and overloading and short circuit. So these all terms we should be learning in this topic. These are the main points. And next, so here there is a circular loop. So we should be discussing this chapter. And here next. Okay. So first of all, magnetic effect of electric current. So first we discuss about the magnet. So what is a magnet? So here the magnet is contain two poles. One is south pole and another one is a north pole. Okay, dear students. So first of all, we should learn about the magnet. So we are getting a different types of magnet, bar magnet, and next horseshoe magnet. So and magnetic needle. So these are different kinds of magnets we are getting. So here we should use a bar magnet. So every magnet should contain two poles. One is north pole and another one is a south pole. Okay. First of all, we have to learn that magnetic field lines are passed around the magnet, around the magnet. So here how these properties of magnetic field lines we should be learned. So okay. So whenever we see the magnet, so magnetic field lines are more at the poles. So there are two poles, south pole and the north pole. If we cut this magnet into two halves, what will happen? Again we can produce south pole and north pole, and north pole and south pole. Okay. So here magnetic field lines more at the poles. So here when we see the properties of magnetic field lines, okay. So magnetic field lines are emerged. They comes out through the north pole and they should be end in the south pole. So outside of the magnet, when we see the outside of the magnet, magnetic field lines they are emerging from the north pole and ends in the south pole. This is the basic concept we have to learn. Okay, so here the magnetic field lines emerge at the north pole. North pole to the magnetic field lines are emerging and they are ending in the south pole. And next, the magnetic field lines are closer at the poles. Okay, when we see here, so they are very close here. Magnetic field lines they are never intersect. They are not intersecting each other. Every lines are separated and they are parallel lines. Okay, they are coming from the north pole and they are emerge at the south pole and they are parallel to each other, and at the ends or at the poles we are seeing more and more magnetic field lines. So that's why attraction power, so attraction of iron particles are more in the which one? North and south poles. Okay, the magnetic field lines do not intersect each other. I already said that the magnetic field lines they are parallel, they are not intersecting. So these are some basic properties we should be followed. So here the question, very important question will be asked for your examination. So here, what are the properties of magnetic field lines? So dear students, you have to write the answer. The magnetic field lines are emerged from the north pole and merge at the south pole. This is one point. And next, every magnetic field lines are closer at the poles. So when we come to the poles, so they are very close, and when we see that outside, so they are very far away from us. Okay. So next, magnetic field lines do not intersect. They are not intersecting. And here one of the main important. So when they are merged at the So they are emerged at the north pole and merged at the south pole. So inside the magnet, these magnetic field lines are moving from south to north pole. So this one we have to clarify. This is about the magnet, and next there is a magnetic field lines. Okay. So here, if we kept a compass near the magnet, what will happen? Okay, so if magnetic compass is placed near the conductor carrying a wire, a needle is deflected. Okay, this phenomenon, this is the experiment given by Oersted. So this is Oersted experiment. What Oersted can say? So whenever in any conductor the current is carries, it can produce a magnetic field around the conductor. So this is the Oersted experiment. So here, if you can think that this is a conductor, so in this the current will passes. If the current will passes, it can create a magnetic field around it. So magnetic field can produce electric current. So this phenomenon we should be learn. And next, there is a right hand thumb rule. So this is a very important rule given by the Maxwell. So here, according to this rule, what is happening? So here it is considered this is a straight conductor. So if current is passes from this direction, this is west to east direction. So just we can, according to this rule, we have to understand so how the magnetic field is produced in this straight carrying conductor. If the current is passes from west to east direction, what is the direction of a magnetic field? Okay, let's we have to assume this. This is a thumb and these are the wrapping fingers. Okay, what will happen? So here, when the current will passes from west to east direction, so this thumb can show the direction of electric current, and these wrapping fingers are showing magnetic field direction. Okay, just we can see that. So if the current is passes through west to east direction, so we have to place this thumb, and here these wrapping fingers, they are north to south. The direction of magnetic field is north to south. If the current is passes from east to west in that time, so the magnetic direction, the magnetic field direction is south to north. So this one we have to conclude. And if the current is passes from this one, the current is passes from south to north, what will happen? So here this west to east, so same east to west. So by this we have to conclude that the direction of magnetic field by using right hand thumb rule. So it states that if a current carrying conductor is held at the right hand such that the thumb points the direction of current. I already said the thumb is pointing the direction of current, and then the fingers wrapped around the conductor show the direction of magnetic field. So these fingers are showing the direction of magnetic field. This is given by the Maxwell. Okay, so here the magnetic field. So how the magnetic field is generated? Okay, so here the region around the magnet where the force of attraction or repulsion can be detected is called as magnetic field. Okay, if we take a bar magnet, there are two poles, north pole and a south pole. Okay, if we can take a south pole near to the south pole of another magnet, what will happen? There is a force of repulsion because of like forces are repulse each other. And if we take a north pole towards the south pole, it should be attract because of opposing poles are attract each other. So here this is caused by the magnetic field. A magnetic field around a bar magnet can be detected by using a compass. So by detecting using by the compass. Okay. So if we can see the north and south pole, so here the compass is there. So if a north pole is there, so if it is north pole, it is deflected. Means it is repulse each other. So like this we can conclude that the magnetic field is around the magnet. So it is we already know that magnetic field lines are emerged by the north pole and merged at the south pole. Next we have to learn about the solenoid. Solenoid means, so solenoid is a circular coil of wire of shape of cylinder. Okay, we can see that this is the shape of cylinder. So when we take a cylinder and if we wrap wire and two ends of the wires are connected to the battery, so positive and negative. So in that time it is also behaves like a bar magnet. So whatever the magnetic field produced through this solenoid, it is also like a bar magnet. Okay, solenoid is a circular coil of wire in the shape of cylinder. When current flows through a solenoid, it behaves like a bar magnet. The ends of the solenoid behaves like a north pole and south pole. Okay, when the current is passes through this solenoid, these two ends are behaves like a north and south pole. The magnetic field produced by a solenoid is similar to the magnetic field produced by a strong magnet. So strong bar magnet, how it should be produced as a magnetic field line. So as the same way, the magnetic field which is produced by the solenoid, it is also same as equal to the bar magnet, and the strength of the magnet depends upon the strength of the current and the number of turns. Okay, let's we can learn about one thing. So if I can wrap more and more and more and more coil or more and more wire, what will happen? The magnetic field produced by this solenoid is more. If we can increase the number of turns of the coils, so coil number should be increases, automatically the magnetic force or the magnetic field is also increases. And next, if we can increase, so for example, if I use 5 volt of battery, so 6 volt of battery, so if how I can increases the current, so here the current how it is increases, automatically the magnetic field also increases here. So just we have to learn that. So here, what is solenoid? So what is solenoid? It is also acts as a bar magnet, and what magnetic field is depends upon two things. Here one is current and another one is a number of turns of the coil. So here solenoid, it is a circular shaped, and a coil of wire is in the circular shape, and two ends are connected to the battery. So it is produces a magnetic field, and it depends upon coils, number of turns of coils, and next it depends upon the current. If we increase the current, automatically the strength of magnetic field of this coil is also increases, and if we increase the number of turns of the coil, automatically this magnetic field also increases. Okay, so next we have to see here. So the strong magnetic field inside a solenoid can be used to magnetize a piece of magnetic material like soft iron when placed inside a coil, such as a magnet called electromagnet. So here, what is electromagnet? Electromagnet is nothing but, so magnetic field what is produced inside the solenoid. So this can be generated. So material like soft iron can place it inside that. Such a magnet is called as electromagnet. If electric current is passed through the wire around a piece of soft iron, it behaves like a magnet. When electric current is passes, this behaves like a magnet. So this is called as electromagnet. Dear students, we have to learn about the solenoid and what is the electromagnet. So what is electromagnet and what is solenoid, and on what factor the strength of magnetic field of a solenoid should be depends. Next, here the motion of the magnet with respect to coil and changes and induced current. So here motion of the magnet with respect to coil produces induced current. So it is one of the experiment. So here through which what will happen. So if we know that the electric current will passes. So around that there is a production of magnetic field. This is Austin experiment. So here one of the experiment, that is Faraday's experiment. So in this experiment what we learn, so Faraday's experiment state that, so here when a circular coil is there, so through that circular coil if we pass a magnet, what will happen? There is a production of electric current. So this experiment, so here Faraday can use a cardboard cylinder. So in that cardboard cylinder he wrapped or he wounded. So there is a number of turns of copper wire, and two ends of the copper wire are connected to the galvanometer. So what actually this phenomena? So when Faraday push the magnet inside the coil, what will happen? This magnet is producing magnetic field. So this magnetic field can produce electric current, and there is a deflection in the galvanometer. Okay, when Faraday taken this magnet outside of the coil, what will happen? Actually again there is a change in the magnetic field. Change in the magnetic field can produce electric current. So when we taken outside, what will happen? Again the current will be shown, but in this case the deflection is the opposite side. Okay, so first in this deflection, and here when we remove outside, so the deflection is different. So this phenomenon we should be learned. So here if we increase electric current, so we are following some of the points. So here what are the points? So we can, if we increase the electric current inside the coil, we can use more and more strengthened magnet. So if we can increase the strength of the magnet, if we can increase the strength of the magnet, the magnetic field around the magnet will be more. So this can help to increasing in the electric current. So if we can increase the number of turns of the coil, so if we can increase the number of turns of coil, automatically the current is also increases. So this is about the Faraday's experiment and how it can be produced. And here there is a which one? That is self-induction. So okay, if we can take one bar magnet inside one coil, so it can produce electric current. So here also the same thing. When we apply battery, so already here we can conclude two things. Current carrying conductor produces magnetic field. Magnetic field produces electric current. So this is one type of induction, mutual induction. So in this mutual induction, what is happening? When we apply the battery to this one first coil, there is no connection with the second coil. What will happen actually? So here, when the battery is connected, so this is act as a magnet. So this is a solenoid, and this act as a solenoid, and it can produce magnetic field lines around this. So these magnetic fields are entering into the coil 2. In this case, the coil 2 is connected to the galvanometer. This shows the deflection. If we can close this one, so if we can remove the current which is passed by this battery to this coil 1, so if we can remove the current, what will happen? There is no deflection because of it. This current can produce magnetic field. This magnetic field can help to produce current inside the coil 2. So this is the mutual induction. Okay, so take two coils of wire wound around a cylindrical paper roll. Connect one coil to the battery. One coil is connected to the battery and other coil connected to the galvanometer. So what phenomenon is happening? I explained to you. So here current is passed through the first coil. So if we can pass the current in the first coil, the galvanometer needle show deflection in the second coil. This galvanometer shows the deflection. If the current is disconnected, so if this current is disconnected, so there is a opposite deflection, it will be shown. There is no deflection in the second coil. This shows that current induced due to change in the magnetic field. So okay, according to Faraday's experiment, so when the magnetic field will be changes, in that time, what will happen? The current is induced inside the coil. Okay, so here the direction of force of a current carrying conductor magnetic field is given by Fleming's left hand rule. Okay, just we can observe this one. So here Fleming's left hand rule. So according to Fleming's left hand rule, so you should take three fingers of his left hand. Okay, this is a thumb and this is a forefinger and this is a middle finger. Okay, by using these three fingers, we can show that. Okay, so this is the direction of force according to Fleming's left hand rule. This is the direction of force and this is the magnetic field and this is the induced current. Okay, so it states that if we hold the thumb, forefinger and middle finger of the left hand perpendicular to each other. Perpendicular to each other means these three fingers can think. So this is a 90 degree and this is also 90 degree. So when we take these three fingers perpendicular to each other, what will happen? So here each other such that the forefinger, this is the forefinger, it points out in the direction of magnetic field and the middle finger in the direction of current and thumb shows the direction of force or motion of the conductor. Okay, so we learn in the these rules are applicable and these rules are helping in the electric motor. And next Fleming's right hand rule. So Fleming's right hand rule. So it is also, so okay, how we can take a left hand? So Flemings can take again the right hand. So these three fingers are perpendicular to each other. So here this is motion or force, and this is a magnetic field. And next there is an induced current. So here we have to learn about the if the thumb, forefinger and middle finger of the right hand held in perpendicular to each other, such that the thumb points the direction of motion of the conductor and forefinger points in the direction of magnetic field, and the middle finger shows induced current. This is called as Fleming's right hand rule. Okay, dear students, you can practice these two rules for Fleming's left hand rule and the right hand rule. So these are very important. Okay, up to this we have to learn that Fleming's right hand rule and the left hand rule. Next we have to learn about the difference between alternate current and direct current. Okay, so how this direct current and alternate current is flowing in the conductor. A current that always flows in one direction only is called as direct current. The current we get from battery is a direct current. Okay, so direct current it is not moving in different direction. It is moving in only one direction. Okay, here the graph is there, direct current. Okay, it is not changing its direction. It is flowing in one direction only. So that's why it is direct current. It is stored and it is present in the battery. And next alternate current, a current that reverses its direction periodically is called alternate current. So here when we see the graph of this alternate current in the every period, so it can change its direction. Okay, so it can change its direction. So here most power station in our country produces alternate current only. Okay, so most of the power stations like hydraulic power station, and next we have to see thermal power station. So most of the power stations they can produce alternate current. So their changes 1 by 100 second in its and its frequency is 50 hertz. So we are getting this 50 hertz of frequency of electric current in 1 second. And one advantage of AC over DC is that it can be transmitted over long distance without much of loss of energy. For example, when we see alternate current and direct current, so direct current is storable, and if we can transmit with a very long distance, direct current can lose more and more energy, but alternate current cannot be lose more and more energy. So this one, it is one of the important thing. So in examination, what is the difference between alternate current and direct current? So if the question is asked for you, you have to write these answers. And next, so next is for household purpose, how the electric current is transmitted. So here from first we have to see that, so there is a fuse, and next the electric meter, and next the distribution box is there, a main switch and the fuses, and inside the rooms how we have to take the supply of electric current. Okay, electric power to home is supplied through the mains. So main supply, and it has two wires. One is live wire, so that is called as positive wire with red insulated. So in different countries they are using different types of colors of wiring, but in India we are using red insulation wire is live wire. It is positive and it is and the other is neutral wire, that is called as negative. It is black insulation. The potential difference between two wires, it means live wire and neutral wire, that potential difference is 220 volt, and the earth wire with green insulated is connected with a metal plate and kept inside the ground. Okay, so earth wire is also very important. So earthing, so we should, it is necessary to do the earthing. So it is also one of the main question. So why the earthing is necessary? So if excess more and more current will be flows in the live wire and neutral wire, so in that time it should be, earthing should be prevent the electrical shock. So that's why earth wire, so it is connected to the metal plate and it is kept into the ground. So two separate circuits are used. One is of 15 ampere of appliances with high power rating like geyser, air conditioner, etc. Okay, so here whatever we are using, so high power appliances we are using 15 ampere. So of electric current, and other 5 ampere for fan, bulb and different appliances are connected in parallel. So that every appliances get equal voltage, and even one is switched off and other are not affected. So the appliances having metallic body like electric iron, refrigerator, their metallic body is connected to the earth wire, so that there is leakage of current passes through the earth and prevents the electric shock. I already said that. So earthing is very necessary, because of if any leakage of electric current will happen, it will flow through the earth and it should be moved. And next there is electric fuse. So why the fuse is necessary? So if fuse is acts as a protective device. Okay, so fuse is a safety device used in electric circuit to protect the circuit and appliances from the damage due to the overloading and the short circuit. Sometimes what will happen, the more amount of current is introduced into the electric circuit. When the current will flows in the circuit, first it will goes to the fuse. So fuse, if fuse wire is contains a wire, so when excess amount of current will passes, more amount of current will be passes. For example, 5 ampere fuse we are used. So 6 ampere current will become, means that wire get melt. So that stop and that breaks the circuit. In that time the current will not flow further. So that's why it should be stopped and it should be protect from the devices from the damage of overloading and short circuiting. Okay, so here it is a wire having high resistance and low melting point. Okay, dear students, first we have to learn that the fuse wire is having low melting point, because of if high current will be produces, it can produces heat. So if more and more heat will be produces, and this the wire should be melt and it breaks the circuit. Fuse wire is made of metal or alloy. So you know that alloy is a mixture of 2 or more metals, or metals and non-metals. So by that we have to use materials like we are using lead, tin and aluminium and copper. Okay, these are the some materials we have to use to make the fuse wire. And fuse wire is connected in series with the live wire. Okay, through that live wire only the more and more current will be passes. So it is connected in the series with the live wire. And next is overloading. What is overloading? Overloading is caused due to the increase in voltage, or the live wire and neutral wires comes in contact, or if too many appliances are connected in single socket, it results overheating of wire and causes damage to the circuit and appliances. Okay, overloading means, so at what time? At what time the overloading is caused, and how to prevent this overloading? Okay, first of all we have to learn that overloading, how it is caused. It is caused by increasing in the voltage. If suddenly voltage is increases, what will happen? More amount of current will be passes. And if we can, if live wire and neutral wire both come in contact, so in that time there is a overloading. And next, if too many appliances are connecting in the single socket, so we are having habit. So in one socket only we are connecting charger, and we are operating refrigerator, and we are operating TV. So all the appliances are connected in single sockets. In that time it requires more and more electric current, and it requires more voltage. So due to that, excess amount of current will be passes, and this overloading can cause. And how to prevent this one? So overloading, so we can see that live wire and neutral wire does not come in contact. And next there is a, we should not connect more and more appliances in a single socket, so we can use this one. And next is short circuiting. Short circuit is caused when live wire and neutral wire comes in contact, and current suddenly increases in the circuit, and it sparks fire and damage the circuit and appliances. Short circuits. So at what time it will be happen? Live wire and neutral wire. If both are come in contact, in that time it can produce a spark and it can damage the circuit. So this time the short circuit will be happen. So to prevent the short circuit, we have to apply the electric fuse. Okay, so dear students, so here the main topics we learn in this chapter. So you have to learn what is electric fuse and what is the use of it, and what is overloading and how to prevent the overloading, and what is short circuit and how to prevent the short circuit. So these all concepts you have to remember and learn Fleming's left hand rule and right hand rule, and write the difference between alternate current and direct current, and how to find the direction of magnetic field in the straight current carrying conductor and in the circular loop by using Maxwell's right hand thumb rule. So you have to practice more and more for your examination. Thanks for watching me. Thank you everyone.